So hello everyone. Today in this video we will discuss about the numerical problem related to the two hinge arcs. So we have a question. You can see here we have a question. Two hinge arcs of a span 30 meter. So in this figure you can see the span is 30 meter is given over here. You can see span is 30 meter. Okay, and a rise of 5 meter, and the rise height is given 5 meter total. Carries 2-point load, each of 50 kN, acting 7.5 meter and 50 meter from the left end. So from the left end, this one is left side. Okay. So from the section A, first load is this 50 kN, which is acting 7.5 meter. You can see here in this question from the left side, and another one that is again 50 kN, which is acting 15 meter. You can see here this one is whole here to here is 15 meter. So this is 7.5, and from here this is 7.5. So total will be 7.5 plus 7.5, 15 meter from this left to this one. So total is 15 meter from left side, that is 50 kilonewton load is acting over here. Okay, and now you can see in the given question the moment of inertia values at the second of the slope. Okay, so this is given in the question, and determine the horizontal thrust carrying out the appropriate integration. So in this question we need to calculate horizontal thrust. You can see here we need to calculate horizontal thrust. Okay, and these two loads are given in the question. First one is 50 kN and second one is 50 kN. These two loads are acting 7 from this left side. You can see here first one acting 7.5 meter and second one is acting total. You can see this one is total 15 meter. Okay, and we need to calculate horizontal thrust. Okay, so for this we have to just apply the formula. This is very simple. So as you know, horizontal thrust for the different section we have different formula. Okay, for the point load, for the UDL, and for the UBL we have different formula. So you can see here. So in very first we need to calculate horizontal thrust due to this load. Okay, due to this central load. So you can see this 50 kN acting as a center of this arch. Okay, which is acting 15 meter from the left side, and the height of this total is height of this arch is 5 meter, and length is given this 30 meter. Okay, so for the central load, central concentrated load, we have a formula H equal to 5 upon 8 WL by H. Okay, so we have to just apply the formula 5 upon 8. So this we have formula. Okay, so due to this concentric load, we have formula H equal to 25 upon 128 WL upon H. Okay, so we have just all the formula given by the question, and we have to just put this value in this given equation. So this is 25 by 128, and the value of W is, you can see here, this value of W is 25. If 50, we have to just put, and the value of L, that is the length of the whole span is 20, 30. So we have to just put here, and the value of H is 5 meter. So 120 into 5, and after calculating you get the horizontal thrust due to this load only, concentrated load, that is 58.59 kilonewton. Okay, when we put the value of WL and H in this given formula, you can directly get this value, that is 58.59 kilonewton. Okay, so this is acting on the center of this span. Now we have a two different load, so we have calculated horizontal thrust due to this first one load. Okay, this first one. Now we need to calculate horizontal thrust due to this second load, that is 50 kilometer. You can see here, which is acting 7.5 meter from left of the span, that is point A. Okay, so in this case we have the value of A. Okay, the value of a small a, we have this 7.5. Okay, and for this we have formula. Wherever the load is acting at a certain distance from left side or right side, at value a, that is the value of a is now 7.5 meter is given by the equation. Okay, and whenever this load is acting like this here also, and we have this distance from right side to this point load, that is taken a. Okay, so in this case we can see here the value of a is 7.5 meter. Okay, and the value of w is this 50 kilometer. Okay, and length is already this 30 meter. Okay, now we have to just put this value h, l and a in the given formula. Okay, so you can see here, now we are taking this load. Keep in mind, we are taking just this load 50 kilometer, and distance is this one 7.5 meter from the left side, this much. Okay, so now put the all the value in this given formula. This formula is used for the certain distance from left side or the right side. So the formula is equals to 5 by 8 w a by h l cube, l minus a l square plus al and minus a square. So put the value 5 by 8, the value of w, that is this one 50 kilonewton. A, I have already told you, value of a is 7.5. The value of h is this one 5 meter, and value of l is 30. So we have to just put the value 30 and l 30 cube. Now l minus a, so L means 30 minus A means 7.5. So this 7.5, and L square. L square means 30 square, and L square plus AL. A means 7.5. L. L is 30, so just put the 30 minus A square. A means 7.5, so 7.5 A square. So after calculating this all the value, you get horizontal thrust due to this point load. Okay, due to this point load, that is 41.74 kilonewton. Okay, so this is this horizontal thrust acts due to this 50 kilometer point load acting from 7.5 meter. And this we have also calculated another h1, that is 58.59 kilometer. This horizontal thrust act due to the force of this 50 kilometer. Okay, this 50 kilometer. So individually we have calculated two different thrusts, that is h1 and h2. Now for the total thrust we need to just add these two value. So for the total horizontal thrust, you can see here h equal to h1 plus h2, and you just take the value h1 equal to this one, h2 is this one, and h1 this one value, and adding this 58.5 and 48.7, we get 100.63 kilonewton. So this is total horizontal thrust. In this way we can calculate the total horizontal thrust acting on this type of arch. Okay, whenever the load is acting at the center of this span, or acting at a certain distance from the left side, either left or right. Okay, so thank you everybody, thank you for watching.